Dear students, I hope you all are fine and doing well. Today I have come up with the chapter Dual Nature of Radiation and Matter, the second lecture. In this lecture, I have to explain about the graphs on experiment basis in photoelectric effect phenomena. So let's get started. The graphs on which basis? Experiment basis. Hertz and Leonard, scientists, they made an experiment to explore the photoelectric effect. They took evacuated glass tube like that. Here is anode, here is battery. This is evacuated glass tube. This is cathode. This is anode. This is ammeter. This is battery. This is the window. So light ray allowed to fall on cathode, and electrons, due to photoelectric emission, they started to go towards anode. Due to that, the current was noticed in the circuit. Okay, that current is photo current. What happens? There are three uh, points which are very important to note. They are: first, the variation of intensity of incident radiation or incident light, you can say. I think it would be better to write incident light. Second, potential difference between two plates. And third, frequency of incident light. These are the three physical quantities which defines the nature of the graph in this experiment. What you find here in this experiment, anode, this is the plate known as anode, and this is plate known as cathode. This is known as emitter also. This is known as collector also. Whenever anode is kept on positive potential with respect to cathode, then electrons are attracted towards anode. Okay. And what happens? Photocurrent is formed. A time comes when all the electrons emitted by cathode, they fully, completely reach anode. In that case, the current in the circuit was found to be maximum, that is saturation current. Now, in the case when the first case, When intensity of incident light, first graph, when intensity of incident light and current both are related to each other, when it was observed that what happens of the intensity after changing the intensity of incident light about the current, that is photocurrent. So we see here the intensity of incident light, intensity of incident light and photocurrent I. The variation of intensity and photocurrent I. It was found that a straight line means directly proportional. The photocurrent and intensity both are directly proportional to each other. As you increase intensity, the photocurrent increases. Keeping frequency of the incident light and potential difference constant. Potential difference and frequency. Frequency of incident light and potential difference between both plates. Both plates means emitter and collector. It was kept constant. Then this variation, this graph was found. Now the second, another, when the graph between I and V, potential variation of potential difference between the plates and current. I and V. V is the, when we check the variation of photocurrent and potential difference. In this case, what happens? It was found that the on different intensity, this is I1 and I2, where I2 is greater than I1, the intensity was varied, intensity of incident light varied, but frequency was constant. In that case, there was a retarding potential, that is the potential of anode with respect to cathode. If that is, if the potential of anode is kept negative with respect to cathode, then that potential is called retarding potential, because in that case electrons emitted by cathode, they are repelled by anode. So retarding potential is very crucial word here. So this is retarding potential. In negative, certain negative potential V, that is retarding potential, we can say VR, retarding potential. At this particular moment, we see that intensity was different, but retarding potential, that was a certain potential, but frequency was, in both the cases, frequency of the incident radiation, incident light is the same. Okay, a certain negative potential That is a certain retarding potential at which current becomes zero, that is known as cutoff potential. Okay, we can say here, we can write here, cutoff potential is certain negative potential of anode at which current stops, that is known as cutoff potential. Okay, so this is the certain negative potential at which current is zero. This is known as cutoff potential. Okay, now another variation of frequency. Variation of frequency, again I and B. Suppose there is a saturation current here, intensity saturation current is here, and two different suppose this is V naught 1 minus this is V naught 2 negative potential. This is frequency nu 1, this is frequency nu 2, and this is the maximum intensity, that is saturation current. At saturation current, maximum intensity is maximum, that is at a particular maximum current, at a particular current that is maximum, and intensity is I, then in that case we see that different frequency of incident light correspond to different negative potential, that is cutoff potential. This cutoff potential, this is the potential on bigger frequency. This potential, this cutoff potential was observed here. Nu2 is greater than nu1. Bigger value of incident frequency of incident light, bigger amount magnitude of intensity, bigger magnitude of frequency. Okay, the bigger cutoff potential is required. In this case, we see that suppose this is the cutoff potential is V, the energy required is EV naught. This is known as the energy that stops the current. EV naught is equal to half MV max square. Okay. Now another graph. Frequency is here and retarding potential is here for two different metals. This is nu 1, this is nu 1, this is nu 2. This is the threshold frequency for this metal 1, and this is threshold frequency for another metal 2. In this case, this threshold frequency is minimum. So this metal is more sensitive, photosensitive. So these are the four important graphs on the basis of experiment of photoelectric effect. So Uh, I think your concept is clear now. Today's lecture is going to end now. We will see very soon for the next definition. Take care. All the best.